In section 7.2, we will be introducing the trigonometric functions for acute angles. When you see acute angle, this is an angle whose measures is less than 90 degrees. And this is a right triangle. So when you say right triangle, one angle measures 90 degrees, or there is a right angle in this right triangle. So in this right triangle, this is the hypotenuse, which is the longest leg of this triangle, and these two legs, these are the other sides of this right triangle. So in defining trigonometric functions for acute angles, we will be using the concept of Pythagorean law or Pythagorean theorem. So this Pythagorean theorem or law states that in a right-angled triangle, the square of the hypotenuse, or the square of the longest side, which is c squared, is equal to the sum of the squares of the other two sides, which is a squared plus b squared. So this is called the Pythagorean equation. And in this Pythagorean equation, when you want to solve for this hypotenuse or the longest side, you will get square root of both sides, which will be equal to c is equal to square root of a squared plus b squared. Take note, you will disregard the negative here because c refers to the distance or the hypotenuse of this right triangle. And you cannot distribute the square root in this a squared plus b squared because the radicand contains a sum. And if you want to find for a, for one leg of this right triangle, this is equal to the square root of c squared minus b squared. You will start with the longest side, square of the longest side or the square of the hypotenuse minus the square of the other leg. And if you want to find for the other leg, which is b, this is equal to the square root of c squared minus a squared. As you can see here, if you are finding for one leg of a right triangle, so this is always equal to the square root of c squared. You will start with the square of the longest side, which is c squared, and then minus the other leg. But if you are finding for the longest side, which is c, that is equal to the square root of a squared plus b squared. So take note, all of this should always be positive. So let's have an example. So with this given right angle triangle, we will find the value of x. So as you can see here, the legs are x and 15, and then the given hypotenuse is 17. So to find for this x, which is one of the leg, so this x is equal to the square root of the square root of 17 minus the square root of the other leg. And then you will just compute this, which will give you equal to 8. So we now have an 8, 15, 17 right triangle. Let us now introduce the trigonometric functions of acute angles, which is defined as the 6 ratios of lengths of the sides of a right triangles. So we can see here a right triangle and the angle theta, and opposite to angle theta is the side B, and adjacent to angle theta is the side A, and the hypotenuse is C. So with these legs ABC and the angle theta, so we can define the 6 trigonometric functions, which is sine theta, which is written as this. Sine theta is equivalent to B over C, meaning sine theta is opposite over the hypotenuse, which is B over C. And then for cosine theta, then abbreviation of cosine theta is cos theta. Cosine theta is adjacent over the hypotenuse, which is A over C. And then for the tangent theta, the abbreviation for tangent theta is tan theta. That is equivalent or defined as opposite over adjacent, which is B over A. And then for the remaining of the functions, so these are the 3 basic trigonometric functions, And these are the other trigonometric functions, which is cosecant theta, or you can write this as CSC theta, cosec theta. So this is defined as hypotenuse over the opposite, or C over B. So as you can see, this C over B is the reciprocal of this B over C. So you can say that cosecant theta is reciprocal function of sine theta. Then for secant theta is defined as hypotenuse over the adjacent, which is C over A. And the abbreviation of secant theta is sec theta. And if you can notice, this C over A is the reciprocal of this A over C. So we can say that this secant theta is the reciprocal function of cosine theta. And then lastly, for cotangent theta is defined as adjacent over opposite, or A over B. And cotangent theta is written as cot theta. This A over B is the reciprocal of B over A. So we can say that cotangent theta is the reciprocal function of tangent theta. So be familiar with the reciprocal functions: sine and cosecant, cosine and secant, tangent and cotangent. Or we can easily memorize the definition of sine, cosine, tangent, cosecant, secant, and cotangent by these mnemonics. You can read this as SOHCAHTOA. SOHCAHTOA, this S stands for the sine, opposite over hypotenuse, and the C stands for cosine, which is adjacent over hypotenuse, and this T stands for tangent, which is opposite over adjacent. And then for the remaining of the functions, it's just the reciprocal of these three. Cotangent is adjacent over opposite, and then the reciprocal of cosine is secant. Secant is hypotenuse over adjacent. And then reciprocal of sine is cosecant. So cosecant is defined as hypotenuse over opposite. So let us solve this example 2 using the definition of trigonometric functions. Find the value of each of 6 trigonometric functions of the acute angle theta in the figure. So this is the given figure, and as you can see, this is a right angle triangle, or the right triangle. So this is the angle theta, which is an acute, and you can see that opposite side to this theta is this, which is unknown, it's not given, and then adjacent side to theta, which is this side, which is equal to 3, and the opposite side to theta, which is the hypotenuse of this right triangle, is 5. So first of all, you need to find this side, which is the opposite of theta. So to find this, you need the idea of the Pythagorean theorem, because this is a right triangle. So opposite is equal to the square root of the square root of the hypotenuse minus the square root of the adjacent side. And then you would just substitute the values for the hypotenuse and the adjacent, and then solve this, which will be equal to 4. So since we already have the opposite side, which is 4, we can now start defining the sixth trigonometric function, which is SOHCAHTOA. So sine theta, opposite over hypotenuse, opposite over hypotenuse. For cosine theta, adjacent over hypotenuse. For tangent theta, it's opposite over adjacent. So sine theta, the opposite side is equal to 4 over hypotenuse, which is equal to 5. So that will be 4 over 5. Then for cosine theta, which is the adjacent side over the hypotenuse, and that will give us 3 over 5. Then for tangent theta, which is opposite over the adjacent, that will give us 4 over 3. So as you can see, this tangent is just the numerator of sine divided by the numerator of cosine. And then for the rest of the trigonometric function, these are just the reciprocal functions, like reciprocal of sine is cosecant, cosine, reciprocal is secant, tangent, reciprocal is cotangent. So what you're going to do is, instead of defining these three, you will just need to get the reciprocal of these three values. And it will give us 5 over 4 for cosecant, 5 over 3 for secant theta, and 3 over 4 for cotangent theta. Now these are the fundamental trigonometric identities. First is the reciprocal identities, second is the quotient identities, and the third is Pythagorean identities. I will be sharing a magic hexagon for memorizing identities, or if you have any other way in memorizing these identities, you can do that. So just to establish this magic hexagon, we'll be starting completing the functions over this hexagon. So I will be starting memorizing the TSC. TSC, you will put the TSC in this arrow. T means tangent. Next is sine. Next is cosine. Then for the rest, we will be starting for reciprocal identities. So let us start. So for the first reciprocal identities is sine theta, which is equal to 1 over cosecant theta. So here, this is sine theta is equal to 1 divided by cosecant theta. So if you are using a straight arrow, that is division. Again, sine theta is equal to 1 divided by cosecant theta. And that is the first reciprocal identity. The second identity, which is for cosine, cosine is equal to 1 over secant theta. So cosine is equal to 1 over secant theta. So you can see a straight arrow here, so meaning that is division. 1 divided by secant is equal to cosine. So that is for the second reciprocal identities. And then for the third, we have a tangent is equal to 1 over cotangent. So tangent theta is equal to 1 over cotangent theta. So that is the third reciprocal identity. And the arrow is straight. So that's why it's 1 divided by cotangent is tangent theta. Now, for these three remaining reciprocal identities, this is derived from the first three. So since sine and cosecant are reciprocal, meaning cosecant is equal to 1 over sine. So similar to this, sine is equal to 1 over cosecant, then cosecant is 1 over sine. To show in this magic hexagon, so this cosecant is 1 divided by sine. So we will have an arrow here. Cosecant is 1 over sine. And then for secant, this is 1 over cosine. And then for cotangent is this, is 1 divided by tangent. 1 divided by tangent. So these are all four reciprocal identities. And there is more. So from this first three, as I said, you can derive the next three identities. There is another three identities. This is derived from these reciprocal identities. For example, in this first reciprocal identity, if I will cross multiply this, meaning sine theta times cosecant theta is equal to 1. So that is another identity derived from this. To show this in this magic hexagon, so when you say multiplication, you will use an opposite arrows. So for example, sine times cosecant is equal to 1. So sine times cosecant is equal to 1. And then another identity is this, for this reciprocal identity, if I will cross multiply, cosine times secant is equal to 1. So cosine times secant is equal to 1. So like that. Cosine times secant is equal to 1. If I will get another identity for tangent and cotangent, tangent times cotangent is also equal to 1. This is derived from this third identity. So that's the last identity. So what you will memorize in this reciprocal identity is only this first three. If you know this first three, then you will know the rest. Okay? So let us move for the quotient identity. For the quotient identity, so this is division again. So meaning we will be using an arrow, a straight arrow. So for example, tangent theta is equal to sine over cosine. So you can use this. Tangent theta is equal to sine over cosine. So this is straight arrow. It's not an opposite. So tangent theta is sine over cosine. That is the first quotient identity. And then for cotangent is equal to cosine over sine. So cotangent, if the arrow is the other way, cotangent is equal to cosine over sine. So look at that. Cotangent is equal to cosine over sine. Actually, not only that, but we will just focus on these two. For example, if I want cosecant, cosecant and the arrow is like this. So cosecant is equal to cotangent over cosine. That's also an identity. And also, if I put the arrow like this, so secant is equal to cosecant divided by cotangent. And tangent is equal to secant divided by cosecant. So meaning it will apply for this magic hexagon in any other way. Either the arrow is counterclockwise or the arrow is a clockwise direction. But for now, we will focus on these two, which is tangent is sine over cosine and cotangent is cosine over sine. Okay. Then for the last fundamental trigonometric identity is a now for the last fundamental trigonometric identity is about Pythagorean identity. And to memorize this, let's use the first one, which is sine squared plus cosine squared is equal to 1. If you will notice, Pythagorean identities, they're always squared. If you was squared 1, it's also 1. So you will easily remember Pythagorean identities. Everything is with squared. So in this magic hexagon, to be able to locate these Pythagorean identities, I will be using a curve. Not only a straight, not only an opposite, but it's a curve. For example, sine squared plus cosine squared equal to 1. This is the sine, and this is the cosine, and this is 1. So the curve will be like this. Okay, so if the curve is like that, so sine squared plus cosine squared is equal to 1. And then for the second Pythagorean identity, look at this. So tangent squared is equal, sorry. Tangent squared plus 1 squared, which is 1, is equal to secant squared. So it means tangent squared plus 1 is equal to secant squared. Tangent squared plus 1 is equal to secant squared. So it is the same as 1 plus tan squared, okay? Then the last is, the arrow is like that. So 1 plus cotangent squared is equal to cosecant squared. So 1 plus cotangent squared is cosecant squared. So that's it. So again, you can see that in Pythagorean, that they will have three curved arrows like that. So the first one is on top, which is sine squared plus cosine squared is 1. Next is tan squared plus 1 is secant squared. Next is 1 plus cotangent squared is cosecant squared. So that's how you will remember all of this using a magic hexagon. So it needs a practice to memorize this. So you can try, but if you have another way, you can do it. Now let us apply these fundamental identities, which is the quotient identities, the reciprocal identities, and Pythagorean identities. So in this example 3, we will find the exact value of each expression without using calculator. Okay, we will make use of these fundamental identities. So in letter A, tangent 20 degrees minus sine 20 degrees divided by cosine 20 degrees. So without using calculator, so we can solve this as, so we can write this tangent 20, that is the first term, and then you can use, this is a quotient identity, which is sine over cosine, which is equivalent to tangent. So the second term is simply tangent 20 degrees. So here, tangent 20 degrees minus tangent 20 degrees, that is equivalent to 0. And then for the second one, sine squared plus 1 over secant squared pi over 12. So take note, they should have the same angle to apply the identity. So here this is sine squared and this one is secant squared. If you can see here, the squared is in Pythagorean identity. And it looks like this letter B is similar to this first Pythagorean identity. The first term is sine squared, and you can see that 1 over secant squared pi over 12, this is reciprocal identity, which is equivalent to cosine squared. So therefore, we can write this as sine squared pi over 12 plus cosine squared pi over 12. Since this identity is true for any angle, so the angle here, the theta, is pi over 12, So that is equivalent to 1. For letter C, we have cosecant squared 36 degrees minus cotangent squared 36 degrees. So as we can see here, this is in squared, so we can look at Pythagorean identity. So let's see, they have relationship of cosecant and cotangent, and that is on the last identity. But we need the expression which is cosecant squared minus cotangent. So cosecant squared, if you will move this cotangent squared on the right side, it will give us minus cotangent squared, which is the same form as this letter C. So the answer is equal to 1. Okay. And for letter D, sine 80 degrees multiplied with cosecant 80 degrees, it looks like we can apply the reciprocal identities in this case, which is relation to sine and cosecant, so the first reciprocal identity. As you can see here, as I said before, if you multiply two reciprocal functions, the answer is always equal to 1. And take note, you have to make sure that they have the same angle to apply identity. So that is equivalent to 1. So here, if you wanna make sure that you use correct identity, you can verify this in your calculator, but make sure when you press this in calculator, like letter A and letter C and D, make sure that you will solve, you can use calculator in verifying this A, C, and D. Make sure that your calculator is in degree mode. Okay, but if you want to confirm this letter B, make sure when you use this pi, your calculator is in radian mode, not in the degree mode. Now the next trigonometric identity is about complementary angle theorem or cofunction identities. So this complementary angle theorem, I usually call this as CAT, representing the C for complementary, A for angle, and T for a theorem. In complementary angle theorem, we'll be using this first statement that two acute angles are called complementary if their sum is a right angle or measures 90 degrees. When you see acute angle, it is an angle whose measures is less than 90 degrees. So let us give a pair of complementary angles. For example, 30 and 60 degrees are complementary angles because if you will add this, it's equal to 90 degrees. So meaning 60 degrees is the complementary angle for 30 degrees and 30 degrees is the complementary angle for 60 degrees. Another example is 20 and 70. They are complementary because if you will add these two, it's equal to 90 again. So 70 is complementary to 20 and 20 is complementary to 70. And then another one is 10 and 80. They're also complementary because if you will add, it's equal to 90. So there is more. As long as the sum of the two angles is equal to 90 degrees, they are complementary angles. Now, we will be needing this in this complementary angle theorem. Okay, so let us state what is the complementary angle theorem or a CAT. A CAT means the cofunctions of complementary angles are equal. So we already know complementary angles. So we have to identify this time what are the cofunctions. Okay, do you remember in the previous identities we learned reciprocal identities? So this time you will learn what are the cofunctions. Cofunctions are just like co-teachers. Okay, so for example, I am your teacher in pre-calculus. So you have another teacher in lab 2 with pre-calculus. So this this teacher in your lab 2, that is my co-teacher. So something like that. So let us identify the cofunctions in trigonometry. So these are the cofunctions. So for example, if I want to know the cofunction of sine, so you would just add co before the sign. So it's cosine. So sine and cosine are cofunctions. For tangent, you would just add co in tangent. So the cofunction of tangent is cotangent. And the cofunction of cotangent, just remove the co. That is a tangent. And then for secant, you would just add co in secant, so cosecant. So secant and cosecant are cofunction. If you want to know the cofunction of cosecant, just remove the co again. So these are the three pairs of the cofunction. It's easy to remember. But take note, If you remember the reciprocal identity, the reciprocal of tangent is also cotangent, meaning the cofunction and reciprocal functions of tangent and cotangent are the same. But for sine, if you remember, the reciprocal of sine is cosecant and the reciprocal of cosine is secant. So it's the other way around, okay? But for the cofunction, sine and cosine are cofunction, not sine and cosecant, okay? So it's easy to remember. So now, just to complete this theorem of CAT or complementary angle theorem, so since we already know the cofunctions and we already know the complementary, so let's draw a right triangle. So suppose we have a theta and the side AB, the sides AB, and the hypotenuse is C. So this is a right triangle because there is a right angle here. So we can see that the side opposite to theta is this A. So this is opposite of theta. So if this is the opposite of theta, this is the adjacent to theta, which is the B. And then if I will introduce another angle, which is a beta, the side opposite to beta is this, B. And if this is the opposite to beta, then the adjacent to beta is this. So that's adjacent to beta. And the hypotenuse will still be the same. So C is the hypotenuse referring to angle theta, and C is also the hypotenuse referring to angle beta. So if you can see here, um, if this is 90 degrees, and these are two are acute angles, the sum of this theta plus beta is equal to 90 degrees. Because as we know in geometry, if you will add the three angles of a right triangle or any triangle, the sum is always equal to 180 degrees. So if one is 90 degrees, the sum of these two, the theta and beta, is equal to 90 degrees, isn't it? So it means to say, if the sum of the measure of theta and beta are 90 degrees, so it means to say this theta and beta are complementary angles, right? So now we are approaching to complementary angle theorem. So since the theta and beta are complementary and we already know the cofunction, it means to say the sine of theta is equal to the cosine of beta. Why? Because sine, the cofunction of sine is cosine, and theta, the measure of theta plus beta is equal to 90 degrees. So they are always equal according to complementary angle theorem. And the measure of that is A over C. A over C because sine theta is opposite divided by hypotenuse. So A over C using definition of trigonometric function. Okay, so what about the other? So for cosine theta, it's equal to sine beta because cosine and sine are cofunction and theta and beta, they are complementary. So it's the opposite of this. They are related to each other. If sine theta is equal to cosine beta, then cosine theta is equal to sine beta. Okay, so the next two is for tangent and cotangent. The cofunction of tangent is cotangent, and theta and beta are complementary. Again, the tangent and cotangent are cofunction, and theta and beta are complementary angles. That's why they are equal. So same as cotangent theta is equal to tangent beta. And the last, secant, the cofunction of secant is cosecant, and theta and beta are complementary, so that's why they are equal. Same goes as cosecant theta is equal to secant beta. So it's easy to remember if you understand the cofunction and the complementary angles. Now here, we will introduce another way of presenting the complementary angle theorem. So theta is an acute here, and theta is in degrees in these given identities. So for example, if I want to find an expression equivalent to sine theta using complementary angle theorem, we know that the cofunction of sine is cosine, and if I want to find the complementary to theta, I will subtract theta to 90 degrees. So that is why sine theta is equal to cosine of 90 degrees minus theta. Okay? And sine 90 degrees minus theta is equal to cosine of this theta using cofunction identities or CAT. And for example, I want to find what's the value of secant 90 degrees minus theta. So if it's always 90 degrees minus theta, so you will have an idea that you will be using CAT. So secant of 90 degrees minus theta, we know that the cofunction of secant is cosecant, and then get the second angle, which is theta. So that's it. They're equal. And if I want to find for the cotangent theta using cat, so the cofunction of cotangent is tangent, and the complementary to theta is 90 degrees minus theta. So that's it. So all of this given in the first column is in degrees and the second column is in radians. So they're all the same as this. So meaning if you saw pi over 2 minus theta, so it's obvious that you will be using complementary angle theorem or CAT or cofunction identity because cotangent of pi over 2 minus theta is equal to its cofunction, which is tangent of the second angle theta. So it's always pi over 2 minus theta or 90 degrees minus theta for the complementary angle theorem. If this is plus theta, no, you will not use complementary angle theorem. Or if this is pi minus theta or 3 pi over 2 minus theta, you cannot use complementary angle theorem. Complementary angle theorem is only 90 degrees minus angle or pi over 2 minus angle. So let us try this. In example 5, we will write an equivalent expression using complementary angle theorem. So we will practice writing an equivalent expression of this using CAT. So for example, sine 62. If I will do a shortcut, sine 62 is equal to, the cofunction of sine is cosine, right? And if I will subtract 62 to 90 degrees, it's equal to 28 degrees. So meaning, I know that sine 62 is equal to cosine 28. And to have a solution, so the cofunction of sine is cosine. And to get the complementary for 62, subtract 62 and 90. So 90 degrees minus theta, right? This theta, this 90 minus theta. So 90 degrees minus 62 is 28. So meaning sine 62 is equal to cosine 28 degrees. Okay? But if the given is in pi radian, so like for example, tan pi over 12, so the cofunction of tan is cotan, and then pi over 12, so subtract this to pi over 2, not to 90 degrees, subtract to pi over 2. Then just subtract this, it will be equal to 5 pi over 12. So tan theta is equal to cotan of pi over 2 minus theta. So your theta here is pi over 12. And the value of that theta, of the value of the cofunction identity is cotangent 5 pi over 12 is equal to tan pi over 12. Next is cosine pi over 4. I think this is easy because the complementary to pi over 4 is pi over 4 again. So meaning cosine pi over 4 is equal to sine pi over 4. Or to have a solution, the cofunction of cosine is sine, and then subtract this pi over 4 to pi over 2, and you will get pi over 4. See, they are equal. Okay. Next is cosecant pi over 6. The complementary of pi over 6 is pi over 3 because pi over 6 is 30 degrees and pi over 3 is 60. So cosecant pi over 6, the cofunction of cosecant is secant, and then subtract pi over 6 to pi over 2 and you will get pi over 3 of secant. Okay, so that's it. For this example 6, so we will be using identities in finding the exact value of each expression without using calculator. Take note, what I want you to learn here is to apply the appropriate identities to be able to evaluate the following expression. Okay, so do not just use calculator here. So for this letter A, secant 28 degrees minus cosecant 62 degrees. So the first thing that you have to do here is you have to analyze the relationship between secant and cosecant. Okay, so you will recall the identities like reciprocal, quotient, Pythagorean, and the complementary angle theorem, which is CAT. Secant, cosecant. So if you heard me right, I just add co in secant and that is cosecant. So meaning the relationship of these two, they are cofunctions. So now, since I identified the relationship of the function, now it's time to identify the relationship of the angles, 28 degrees and 62 degrees. If you will add these two, it's equal to 90 degrees, meaning they are complementary. So it's obvious that we will be using a complementary angle theorem or a CAT, right? So how to use a CAT in this kind of expression? So what you're going to do is select one function, like for example cosecant 62 degrees. So using CAT, cosecant 62 degrees, you know that cosecant, the cofunction is secant. And to find the complementary for 62, subtract 62 in 90 degrees. So 90 minus 62, you will get 28 degrees. So meaning the value of cosecant 62 degrees is equal to the value of secant 28 degrees. So you will just replace the secant 28 on this second term. So that's it. So secant 28 minus secant 28 is equal to 0. So it's easy. Now for letter B. For letter B, sine 35 degrees divided by cosine 55 degrees. You remember sine and cosine, they are together in Pythagorean. But if you remember in Pythagorean, all of them or the terms are with squared, but these two are not with squared. And there's another relationship between the sine and cosine. They are cofunction, right? Sine, cosine, cosine, sine. So they are cofunctions. So it means to say, let's select one of this to use the cat. For example, I will be using the numerator. Sine 35. Sine 35, to be able to use the cat, the cofunction of sine is cosine, and the complementary to 35 is, I will subtract 35 to 90 to get a 55 degrees. So Sine 35, the value of that is equal to the value of cosine 55. So now we're going to place this here in numerator. So that's it. So now you don't need calculator. Cosine 55 degrees divided by cosine 55 degrees is equivalent to 1. So that's how you will be using the cats. For the next example, example 7, we're going to find the exact value of the acute angle theta. So now I want you to analyze the given function again and check the appropriate Pythagorean identity that you can use. Cosecant squared and secant squared. Remember, both of these are squared. Maybe we can recall Pythagorean identities. But as I remember in Pythagorean identities, the cosecant squared is related to cotan squared because 1 plus cotan squared is cosecant squared. And secant squared, this is related to tan squared because secant squared is equal to 1 plus tan squared. So I think Pythagorean identities are not appropriate to use here. So let's try again. Cosecant, secant. Cosecant, secant. I just remove the co and it becomes secant. And in secant, if I would just add co, it will be cosecant. So meaning I can use a cofunction, right? But we have a squared. I think there's no problem if there's a squared. What we can do here is to get squared of both sides. If we get squared of both sides, then I will get this, right? So no more squared. Cosecant and cosecant and secant are co-function, meaning if I'm using the cat, the sum of these two angles, it's equal to 90 degrees. So that's what I'm going to start with. Since cosecant and secant are co-function, using cats, if I will add these two angles, that is equal to 90 degrees because these are complementary angle. Okay? So it means I will just take these angles, I will add them. I will equate it to 90 degrees and then that's it. That will be my equation. So if I'm solving for theta, so I have to put the theta on the left side and no theta on the other side. So I will get 7 theta is equal to 98 degrees. Because 2 theta plus 5 theta is 7 theta. Then 90 degrees minus 10 degrees and then plus 18 degrees, you will get 98 degrees. And then dividing both sides by 7, theta is equal to 14 degrees. So this is the answer for your expression here. So that is the value of theta. And look, we need to find the exact value of acute angle theta. 14 degrees is an acute. Because if the angle is not acute, you cannot use the cat. Remember, if the two angles are complementary, both of them are acute angles. And take note, do not forget to put a degree unit here because without degree, that is incorrect and you will have deductions for that. Because without a degree, meaning this 14 is a 14 radians, not 14 degrees. Okay, so remember that.